Welcome everyone to our channel, Universal Free Tool. Today, in this video, we will build a bottle capping machine using CODESYS step by step. You will learn how industrial automation works with visualization, sensors, motors, timers, and PLC logic in a simple and practical way. Let's get started.
First, let's understand what is the capping machine. So mainly, the capping machine is composed from capping station, torque station, gating system, reject shelf. On this video, we will show you how to create capping sequence, create visualization, and how to link it to our sequence.
What is a capping machine? A capping machine is an industrial device used to automatically place and tighten caps on bottles, jars, or containers. Its main purpose is to seal products securely to avoid leaks, contamination, or damage. There are different types of capping machines. On this video, we will see chuck capper.
Capping station. A cap is first placed on top of the bottle. Then, the chuck moves down to grip the cap securely. The chuck rotates to tighten the cap onto the bottle threads. Finally, the chuck releases and moves up.
At the torque station, the machine checks and applies the correct tightening force to ensure every bottle is sealed properly and consistently. Gating system. The gating system manages the flow of bottles inside the machine. Using sensors and stoppers, it controls when bottles stop or move to the next station. This ensures proper spacing, accurate positioning, and smooth operation throughout the capping process. The gating system controls the movement and positioning of bottles inside the machine. It stops each bottle exactly under the capping station and torque station to ensure accurate sealing and smooth operation.
Reject shelf removes defective bottles from the production line. Using sensors and inspection checks, it detects bottles with missing caps, cross-threaded caps, or incorrect torque. When a faulty bottle is identified, the reject mechanism pushes it off the conveyor to maintain product quality.
Now, we will explain you a very interesting principle of automation, is the communication between two sequences. All the automation sequences should be very small sequences that communicate between them to keep the code readable and easy to debug.
Here, the first sequence step, step 1 and 2, will send bit to start another sequence, step 10, 11, and 12, and when it's done, it will continue step 3 and 4.
The same technique we will use on the next slides to show you how the gating sequence will communicate with capping sequence. This is the gating sequence when the machine is running, means we push the start button. The conveyors start moving, and the machine will wait for a bottle to reach sensor on capping station. Gate 1 will move out to stop the upstream of bottles. Now we are on step 3. We send bit to start the capping sequence. At the end, it will send us back bit, capping sequence done, and the gating sequence will continue to step 6 to let the next bottle to be placed again on the capping station. Now we are on capping sequence. This sequence will wait for the bit coming from the gating sequence. When the bit reach the motor of capping station run, the cylinder move down and the motor start torquing gently the cap. The speed and torque of this motor should be not so high. The objective of this station is just to put the first 2 threads of the cap. When we reach the step 5, the motor stop and the chuck move up, and the sequence send done bit to the gating sequence to gate this bottle out and send the next bottle. You can stop the video and go back to understand the sequences. Now let's practice on CODESYS. Now we will start fresh new project on CODESYS. We will choose name and location, and we select standard project. Now, we will create our global variable list. So right-click on Application, Add Object, and select Global Variable List. Right-click and choose Insert. A new empty line is created. We will choose Name and Data Type. We will type Bottle Presence at Capping, and data type is Boolean. The same way, right-click and choose Insert, a new empty line is created. We will choose Name and Data Type. We will type Bottle Presence at Torque, and data type is Boolean. Since we have many tags to be created the same way, I will speed up the video, but you can stop video anytime to see all the tags I created. Just you need to follow all the steps I'm doing, and be careful with data type I will choose.
Now we finish our global variable list and we will start creating Program Organization Unit, commonly known as POU. To create new program unit, right-click on Application, Add Object, and select POU.
On the pop-up, we chose the name and ladder logic diagram, and click on Add a new POU is created. We can rename a POU already created. For example, we chose the name Capping Station. I will speed up the video to create the other POU. The objective of those Program Organization Unit is to separate the sequences of the machine and make it readable and easy to debug. I will create alarms, capping station, gating for capping, torque station, gating for torque, and main. All our POU was created, we need now to add them to our tasks. If we didn't add the POU to the task, the runtime will never execute the program on this POU. To add POU to task, double-click on the main task and shows Add Call, and select one task that you want to add to our runtime. We will select all of them one by one. Now we will create the list of local tags of the alarms. Those tags will be used only inside the alarms program. This way helps to organize the program and make it faster for editing.
To create the logic of alarm, we drag and drop from the right side the normally open contact and name it Alarm 1. The same way, Alarm 2 and 3. We can add many as we need. All the alarms are in OR logic, meaning if any alarm trigger will generate major alarm. That can, for example, stop the machine or show pop-up on the screen.
Now, we will create the local variable of capping station program. We need to choose the right name and also the right data type.
Now is the fun part, and very interesting part. We will create the sequence. It will be the sequence of gating for caping station, as we see in the beginning of the video.
But before that, we need to create the logic on the main program. This small program part will be used to start and stop the machine. Later on the video, we will link the start and stop button to see that our machine will run and stop from this logic. It's the same way we explained in our previous video of latch and unlatch. You can stop the video and watch it back to understand the logic. Now we finish the main logic. We will create the logic of capping station. The way we will do the sequence is that on every step, we will move the integer from number to the next number. Example from step 1, when the conditions are satisfied, we will move the number 1 to number 2. And then our step is step 2, we'll wait for conditions to execute step 2 and move the integer from 2 to number 3. This way is a very common way to program the steps on the ladder logic.
Now we will create the outputs of the sequence. The logic will compare the value of the integer seq capping that will move every time the sequence moves from step to step. If the sequence capping integer is equal to 1, the program will execute the output linked to that step.
Now we will create conversion block. This will move the value of our timer to the preset of the timer. We can link that later on the screen if we need. For now, we will give it 2000 milliseconds, which is 2 seconds, for moving from one step to another step. We will copy all the variables of this program, and we pass them to gating for capping. Since our local variables, we can use them even with the same name. The same way we will copy the logic of the capping sequence, and we will paste them on the gating for capping sequence. We make some modification to adapt the program for gating for capping sequence. The same way we copy and paste the output, and we adapt them to gating for capping sequence. Now, we will create visualization for that. Right-click on Application, Add Object, and select Visualization. As we show on the previous video, we drag and drop elements, and we populate their parameters to link them to the logic. We will create capping motor that will run and stop if is running will be green, and when it stop will be gray color. Capping chuck that will move up and down. Gate 1 will move out and in. The same thing for gate 2 will move out and back to keep the bottle moving and stopping exactly under the capping station. We will also create bottle just for a visualization purpose, and button to simulate the bottle presence sensor. We'll simulate bottle presence. Again, this process will take a lot of time. I will speed up the video. Now we will create Start and Stop button, as we create before in the last videos, and we will link it to main program logic. We will start our simulation to see the results.
As you see, our sequence is making mistake. The capping cylinder and gate 2 are moving at the same time. So let's correct our sequence.
As we copy and paste the sequence, we forget to remove the timer on step 3. This timer should be replaced with "the capping is done" from the sequence of capping.
Now, the sequence is good. We see that when we press the bottle presence button to simulate bottle presence, the gate 1 close to stop upstream bottles. Then the capping chuck move down and the motor run. It plugs the first thread and move up. The capping sequence is done. And now the gate 2 open to let the bottle moves since the conveyor is running. Then gate 2 will close again and gate 1 open to let the second bottle to move and be exactly under capping chuck.
We will add some code lines to show that the motor is running on step 2 of capping station. On the visualization code, we will add the green color and gray color code. Now we see that on the step 2 of capping station sequence, the motor should run, and we will see that on the visualization. The color of the motor changes from gray to green to show that the motor is running, and the motor will stop on the step 6. The capping sequence is working as we intended. This video shows you the capping and gating sequence. You can write me comments if you don't understand something, or you have suggestions of some machine you want to build. I will see you on the next video of torque sequence.